Hello, dear students. SK Booty here, welcoming you back to Booty Aviation Training. And we proceed forward with our series of lessons which we are doing on navigation numericals. Now, today's lesson deals with the measurement of distance and different units. Must have heard about nautical mile, statute mile, kilometers. What are these? Statute mile was fixed by law and is 5280 feet, right? What is a nautical mile? And the speed in nautical miles per hour is known as knots. Speed in statute miles per hour is known as mph and kmph in kilometers per hour. What is one nautical mile? It's an angle of 1 minute at the center of the earth, and this arc subtended at the surface of the earth on a great circle. This 1 minute of a great circle of the surface of the earth is called 1 nautical mile. 60 minutes makes 1 degree, and if you go around the earth, it is 360 degrees into 60 minutes. In other words, circumference of the earth is 21,600 nautical miles. And the 1 unit of nautical mile, the equivalent distance is 6080 feet. Although this will not be the same all over, it's the average length of the nautical mile called the geographic nautical mile, or geodetic nautical mile, which we use. Strictly speaking, since Earth is not a perfect sphere, the length of 1 nautical mile near the pole will be more compared to near the equator. That's a theory question. Practically, we use a value of 6080 feet for our day-to-day use. Another unit often used, particularly by Russian aircraft, they work in kilometers, and their ASIs are in kilometers per hour. What is 1 kilometer? When the world was converting onto the centesimal system of working, and India also did that. Some of the countries are still following the old miles per hour, but many countries have changed over to what is known as a nautical mile for their airspeed indicators and kilometers for their ground distances. Many. Okay. What is a kilometer? The idea was to bring this whole thing into multiples of 100, the distance. They decided from the pole to the equator, great circle distance, whichever way you go, from here to here, that this distance from pole to equator or equator to either pole will be 10,000 kilometers. So 1 kilometer becomes 1 by 10,000 part of the great circle distance from pole to equator, and when measured, it worked out to an average of 3280 feet. So the units of distance usually used in aviation nowadays are nautical miles, speed in knots, kilometers, speed in kilometers per hour, and 1.15 statute miles is equal to 1 nautical mile for theory. For practical, more often used unit is 1 nautical mile equal to 1.85 or 852 kilometers. Or you can say 1852 meters. That's what ICAO says. 1 nautical mile is 1852 meters. Now, between these two, the relationship is 3.28 feet is equal to 1 meter. 3280 feet is 1 kilometer. Kilometers got 1000 meters. So 1 meter will be 3.28, and we use a rough value of 3.3. 1 foot here, which we were talking about, is equal to 12 inches. And each inch is equal to 2.54 centimeters. These conversions are available on your nav calculator, but if you remember them, it will be much better for you. Time saving. Now, a point to note is, theoretically, when you are traveling in the air, you are covering a more distance compared to the distance from the ground. Here it is, extend these lines little forward, and then to cover this distance of 1 nautical mile, you will be covering a greater distance in the air. That's only theoretical. Practically, it makes hardly any difference, and we ignore it. Right? What next? Stand by for a few seconds. Sorry, back to the same slide. We can convert d-lat and d-long into distance. We learned in lesson 7 how to calculate d-lat and d-long. Is there any relationship with distance? Yes. D-long has a relationship not only with distance on the earth, it also got a relationship with the conversion angle and convergency, as also the time difference between various countries, which we will study in subsequent lesson. Today, please understand that if you are on a particular meridian, let's say this meridian or this meridian, meridians are great circles, and each 1 minute of a great circle is 1 nautical mile. We know it by now. So here, as you travel each minute, here you are traveling 1 nautical mile, and d-lat in minutes, provided you remain on the same meridian, is equal to 1 nautical mile. So from here to here, distance will become 5,400 nautical miles. Semicircle 10,800, and circumference 21,600 nautical miles. That is distance north-south, traveling towards 000 or 360. When you are traveling east or west, 090-270, you can do it on equator and you will come back to the same point, or you can do it on any parallel of latitude. Keep on traveling 090 and you'll return to the same point. Distance east-west, can this be converted into nautical miles? At equator, this is a great circle in any case. Each minute of change of longitude will be equal to 1 nautical mile. But as you can see now, as we go towards the pole, this distance east-west keeps decreasing, and at pole it becomes 0. Similarly, towards south, this distance east-west at pole becomes 0. What about the remaining parallels? At any other parallel, latitude 5, we can say distance east-west is given the name of departure, is equal to change of longitude in minutes multiplied by cosine of that latitude. As you know, cosine value keeps decreasing. This distance will keep decreasing. So distance east-west called departure is change of longitude in minutes into cosine of the latitude. That is converted d-lat and d-long into distance. And let's cover a little bit more with this lesson. What is known as north and south vortex, and what is the antipodal point. Antipodal point is a diametrically opposite point. For example, north pole, antipodal point will be south pole, diametrically opposite. And at any other place, let's say if this is a great circle going around the earth, and you are at any point on the earth, if I dig through the center of the earth and pass through the center and come out here, where will you come out? That is known as an antipodal point. To calculate antipodal point, one of the simplest questions, if this is place A, place B will be on the other side of the earth. If place A is 35 south, B will be 35 north, antipodal point. Just change the polarity. As far as the meridian is concerned, if you are on 120 east, the other point will be 180 degrees away from you. So 180 minus 120 is 60 degrees. 180 minus longitude of A, 60 degrees. And if you are east, that point will be west. And if you are west, this second point will be east. That is an antipodal point. Fetches you quick marks. Latitude, as it is, change the polarity. Longitude, 180 minus your longitude is your antipodal longitude. If you are east, he'll be west. Then there is a point called north-south vortex, that if there is a great circle track passing through the equator, what maximum north point and south point will it touch in terms of latitude and longitude? That is called north-south vortex. Let's take this track, for example, for the first, starting with. This track is crossing the equator. The track is 050. Track is measured from the meridian. So it will cross the equator. Smaller angle will be 40 degrees. So take the smaller angle, 40 north and 40 south will be your north and south vortex. What about the longitude of these places? See your own meridian. I'm at 60 east. This point will be to the right, 90 degrees to the right. 60 plus 90, 150. Either take the antipodal point or go 90 degrees to the left and you'll get this point. 60 minus 90. 60 is minus 90 will be 30 west. If you have found out one point, take the reciprocal. Second point will be there, antipodal point. Let's take this blue track of 330 degrees. This angle track is measured from the north meridian. So it will, this direction is 270 and track is 330. So smaller angle will be 60 degrees. 60 north will be north vortex. 60 south will be south vortex. Similarly, see your meridian. In this case, I have taken the same meridian. Plus 90. Here, this one will be plus 90. And this one on your left will be minus 90. If it is 70 east, plus 90 will be 160 east. And 180 minus 160, it will be 20 west. That will be your other vortex. So these are the north and south vortex. And how to convert d-lat and d-long into distance. And in the next lesson, we will be continuing or taking forward this topic and use this d-long, etc. for finding out conversion angle, convergency, and what do they mean to us. Okay. And for the time being, it's bye-bye, good day from my side. Happy landings, all the best. And if you haven't done like and subscribe by now, and if you have liked the lesson also, then do it now and share it with your friends. Good luck. All the best. Okay, signing off for the day.